Okay, my wireless mic is not working. It turns on, but I can't get the Bluetooth to connect. I can't put it in discovery mode. And right now I don't have time to research it. So the audio is going to come from here. So if I'm talking and I leave the podium, the audio you'll hear is going to go down a little bit or a lot. Excuse me. All right, so what we're going to do is now next week's lab 2 dry lab, is going to be on problem solving. That's all we're going to do. 2 hours worth in lab. However, what I want you to do is download the first page of the one that I have posted, lab 2. The reason for that is I've highlighted all the definitions that have infinite sig figs. Remember, it's by definition, like how many are in a dozen? 12, exactly. So that means the precision is infinite. So in other words, it's not measured. Your copy, they're just italicized. It's really hard to tell. What I had to do is I boldface everything that's by definition infinite precision. Oh, one thing I forgot to say. Where's student parking? Is it very far away? Yeah. Okay. On Saturdays, park in the staff lot. Okay, which is really close. It like borders the building. Like I was the only one in the parking lot when I drove up there. So they don't check on Saturdays. Okay. Theoretically, you can get a ticket, but that's assuming they're doing tickets that day. And most of the time they aren't. So just play the odds. Okay, so make sure you download this one before you go to lab next week. It's a lot clearer. Also, I added this here. 1 milliliter of water is equal to 1 gram. So add that to your list of conversion patterns. Okay, I also modified the examples. I added examples as well, because I think it lacked that. So this is much better than the ones in your lab. I don't know who did that one, but it's awkward. Okay, so let's look at some problems now. Now, part of conversions are working within the metric system. You're going to be doing that a fair amount in Unit 1. Conversions within the metric system. Now you can think Ronald Reagan for canceling the United States' participation in the metric system. In 1985, 86, something like that. He didn't think it was necessary. We had already spent $10 million converting road signs to be kilometers per hour and all this stuff. But oh no, that was too much work. Oh, yeah. So there are 6 countries in the world that are not on the metric system. 5 third world countries and us. It's like, all right. For example, our system. There are 2 kinds of ounces, fluid ounces and dry ounces. How are you supposed to know which to use? They both have OZ by it as abbreviation. Not so in the metric system. Metric system is very specific about each thing. And everything is by tens as well. It just blows my mind that there was rationale to do that. Okay. All right. Anyway, I want you to get familiar with the metric system. Comfortable in working on it. Some of these, you've all heard of megabytes and gigabytes and terabytes, all that stuff regarding your computer related stuff. You've probably heard of milligrams. When you look on your pill bottle and notice that the active ingredient is in milligrams. Possibly micrograms, and probably not nanograms. All it is a multiple, some kind of tens, whether it's 1,000, 100, or 10. All right. So let's go through 4 steps again. Well, this is totally review from yesterday at the end of the lecture. 4 steps. Steps, always. First step may be optional. There's no chemical reaction going on if we skip first step. When we get to 4, you're definitely going to have chemical reactions going on. So step 1 is required. You've got to balance that equation. We're going to talk about chemical reactions at all. So really, the first step is part of one is concerning what's given. The easiest way to find out what's given is look for the number. We have 15 apples. How many dozen do we have? Okay, so look for the number. This is 15. 15 what? Now, there's another unit in there as well. There's no number associated with it. That's what he's trying to calculate. So with the given on the left, to be calculated on the right. And what goes in between is going to be the conversion factors or fractions. Now, again, this is a review. You should already have this in your notes. Starting with 15 apples. And want to go to dozen. Another note to add here is when you're doing the setup, always cancel the given. So that means the first fraction you're using has got to, the given's got to be on the bottom so that it cancels. It's not on the bottom, it won't cancel. So we're going to have a fraction here. And apples are going to be in the bottom. So it cancels. Now, what's on the top of the numerator has to be what you're trying to calculate. So we want to find a fraction that's got dozen and apples on it. And we have such a beast. We know they're always 12 apples and 1 dozen. By definition. So whenever we do any kind of problem from now till May this semester, you're going to use sig figs. So 2, and as I said yesterday, by definition, anything is defined, it has infinite precision. So that means our answer is going to have 2 sig figs. So it's 15 times 1 divided by 2. Remember, I remember right. Anyone not have a problem here today? Well, you're gonna definitely need to go out. And one calculator. It's going to be borrowed. Okay, so 1.25 dozen, is that the correct answer? Don't everyone answer it or like it's confusing.
Oh, yeah.
Right, remember from yesterday, we have to knock it down to 2 sig figs? Okay, so what the answer should be is what? Okay, so this is like, I consider a one-step problem. That's because we're using one conversion factor, or one conversion fraction. Sometimes we need more than one, because the only way it'll work if we have one step is if the numerator's got the calculated part in, the denominator's got the given in it. That's the only way we can have a one-step problem. Okay, so is that clear? That's the simplest problem you're going to get in Unit 1, is a one-step conversion. Okay, so here we have a metric problem. How many micrograms are in 456 grams? Okay, what's given? What are we trying to calculate? Micrograms. To do a microgram, you do a kind of a fancy M with a long tail on it. Okay. The last step is how do we calculate going from grams to micrograms? And we go back up to our handy dandy table of conversion factors. Okay, so here's a microgram. We have two conversion factors on my table. In your table, you're going to have one. So I want you to download this one. Which one do you want to use? Left or right? Okay. Okay, the right one says we have 1,000,000 micrograms in 1 gram. The left one says we have 1,000,000th of a gram in 1 microgram. Okay, they're the same thing, just viewed a little differently. So we're going to use, someone mentioned the right one, let's use the right one. Now remember, the given has always got to cancel. So what's going to go on the bottom? Grams have got to go on the bottom, otherwise it's not going to cancel. And in the beginning, you might want to be crossing off just like I'm doing. You definitely know it's canceled. Okay, what goes on top is a microgram. Now, there are 1,000,000 micrograms in a gram. Now, the other way we could have done it Okay, this is the same fraction. So let's do that. Let's do the left one first. Okay, so we've got 456 grams times 1. Are we going to put times 1 in the calculator? If you're OCD, you say yes. If you're not OCD, you say no. My second wife was OCD. I know a lot about OCD. And the reason why is my ex-wife was OCD. Okay, so we have 4.56 divided by 10 to the minus 6. So we're going to be using EET now. That's going to be so 4.56 times 10 to the 6 micrograms. And the same calculation up here. Now, if your calculator doesn't have an EET on it, you have to do 3 extra steps. You have to put parentheses, actually 4 extra steps. You have to put 2 parentheses, left and right. You have to put a times 10 caret 6. Those are extra steps if you're not using EETs. Does anyone on their calculator not have an EET? I asked this before, and I don't remember anyone raising their hand. You don't have a calculator, right? Yeah. And there's no EE on that? Okay, if you're buying a calculator, I recommend a TI 36. You haven't got one. The reason for that one is because the EET is a dedicated key. You get a TI 30, you have to do a shift to get to the EE. And then it basically, Amazon same time. If you want it immediately and wait home, go to Walmart. Otherwise, wait a day. You get it. You all know that, you know, as a student, you have 6 months of free time. And then after that, it's half price. As long as you're a student. Okay. Now, if we didn't have the EE key, let me show you what you have to do. You start with 4.56. Hit the divide key. It's on the bottom. Left parentheses. That's what you'd have to do if you didn't have it. Now, if you didn't put the parentheses there, your your calculator is very dumb. It would think you're multiplying by 10 to the minus 6 rather than dividing by 10 to the minus 6. That's why you need the parentheses there. So if you're not using the EE key, always surround scientific notation numbers and parentheses. You won't go wrong. Only problem is, you may have a problem by not inputting the correct key sequence. But it works fine. All right, any questions about that? All right, sorry, what? Did I put in what?
I didn't.
You get a syntax error, right? You might have got a syntax error because when you put the -6 in, did you have a small parentheses? Yeah, you have to have a large. And you put it in as the parentheses in the exponent, should be in the whole number. Huh? You got the same answer?
Yeah.
Okay. Remember, everyone. One, I'm hard of hearing because I'm old. I was born in 1950. I'm probably the same age as your grandparents. That's the vent for this room. And yes, it's noisy. So there are two reasons why you need to speak up. And thirdly, if you're shy, you really need to speak up. Okay. Similar problem. How many kilograms are in 3.04 grams? Let's do that one. Okay. So what is given? 304, right. And we're trying to calculate what? Okay, so we need a conversion factor. Pounds have got to cancel. Kilograms on the top. Okay, so we find a conversion factor going from pounds to kilograms. Up there.
No.
No, that's right. So this is not a one-step problem. First thing we're going to do is we're going to use pounds and grams, and then we're going to use grams and kilograms. So it's a two-step problem. So first step is going to be to grams. And then from grams, we're going to go to kilograms. Okay, and who remembers how many grams are in a pound?
459 grams.
453?
453.59.
Okay, so this is going to give us grams. Next thing we have to do is get it over to kilograms. So the grams have got to cancel. How many grams are in a kilogram? 1,000. So the common unit is gram. What they find in chemistry and physics is a common unit called a mole, M-O-L-E. Everything is related to mole. In engineering, in the biofield, we work with mole itself. All right, so setup is there, 90% of the points. All right, sig fig wise, we have 3, 5, infinite. Okay, by definition, there are 1,000 grams in 1 kilogram. By definition, hence the precision is infinite in terms of sig figs. Okay, so how many sig figs are in our answer? Everyone from Friday's lab should know this. 3. All right, so we go to the 4th place. That's 5 to 9, so that kicks that 7 up to an 8. So the answer is 138. Now, you're gonna have a take-home problem for test 1. I'm gonna give you about 5 days to do it. This is gonna have a whole bunch of conversion factors. The reason why I'm giving you 5 days to do this is because you need to think through all of the conversion factors. Okay, any questions on this guy? Okay, plane travels from San Francisco to LA. 1.5 hours. Jet fuel burns 3.45 pounds per second. How much fuel does the plane use? So, what's given? The 2 numbers up here, which is a given? 1.54 hours. So the other is a conversion factor. You get per pound per second. That's conversion factor, a fraction. We're going to start with 154. Now we can end up with, this is how much fuel does a plane use? You can do this in terms of pounds or kilograms. Let's go with kilograms. Okay, so we're going to calculate kilograms. All right. What's our first conversion? Hours are going to be in the bottom. Perfect, you guys. Okay, what's going to go on the top? Well, there's conversion factor built into the problem, 345 pounds per second. So what's the problem? Okay, but we don't know how many pounds per hour. We know how many pounds per second. How many, we know how many seconds are in an hour? How many seconds are in a minute?
Yes, yes.
How many minutes in and out? Well, that's two conversion factors to get us there. All right. So let's go with minutes. Okay, now we're in seconds. Okay, now we can use the 345 pounds per second. Now we're in pounds. How do we get to kilograms? Yeah, the same problem we had before us. This one here. 453.59. Okay, now we're in grams. We need to go to kilograms, and that's 1,000. So what is left over unit wise? What has not been canceled? Kilograms. What are we trying to calculate? Kilograms. So we're there. %90 of the credit. So how many sig figs does our answer have? Great, great. So to get that extra 10% points, we'd have a correct numerical answer, correct number of sig figs, and a correct units. All three of them. Huh? No, just how much? Just kilograms, yeah. And we're gonna burn that plane's engines for 1.54 hours. We're gonna use up that much fuel. Sunburn is starting to feel. We're kayaking. We did before last night. We forgot our sunscreen, so. My legs are all sunburned, face is all sunburned. All right, any questions about that one? Well, using the 3.45 pounds per second, this is how many pounds we've got. Once we get pounds, that's right here. If we stop there, it would give us pounds, not kilograms. We have to continue on pounds to grams, grams to kilograms. Was that your question?
Well,
Right, right. It just says how much. So if I wrote a vague question like that, you could put either pounds or grams or kilograms. I just said, let's just do kilograms. Yeah, you're right. It was not a very well written question. Yeah.
So, what would you agree on another?
Well, it says how much fuel does a plane use? Doesn't say how many pounds, how many kilograms, or how many grams. I just said, let's do kilograms. But if this was written on a test, you could put pounds or grams or kilograms, doesn't matter. And hopefully in a test, I won't be this vague. Would have been 868 times 10 cubed grams. Yeah. 1,000 kilograms. Now, which is bigger, a kilo or a gram? Kilogram is bigger. That's why. Not a milligram, it's smaller. Kilogram, 1,000 grams for 1 kilo. And remember, all conversion factors, the top and the bottom have to be equal. 60 minutes is equal to 1 hour. They're equal. That's the only reason why we can multiply. Given by that, they're multiplying really by 1. We're kind of renaming the given to the calculator. Or renaming and multiplying by a whole bunch of conversion factors, which remember equals 1. So 1 times anything is this, what you start with. So really we have this times 1 times 1 times 1 times 1 times 1. What we're doing is renaming it. All right. Now, whenever we get into square units, like square feet, square meters, square whatever, we have to treat the conversion factors a little differently. For the cubic feet, cubic meters, cubic yards. So by definition, when you see that is square feet. Cubic feet. So to find out the conversion factor, for example, going from feet to inches. Let's go cubic feet to cubic inches. Now we know there's 12 inches in 1 foot, linearly 12 inches in 1 foot. In German cubic, we have to cube 12. That's what that's equivalent to. Okay. So what is 12 cubed? What's 1 cubed? 1. 12 cubed is 1728. So that's the conversion factor going from cubic feet to cubic inches. Okay, it's very different than doing the linear stuff. Doing a similar calculation for square. So that's square inches per square feet. So it's a very different calculation using square feet or square feet. The reason why that number is so large is because we have to do the square of cubic. Okay, so does that make sense? I'm sure some of you are saying no. That makes no sense. But when you're working with linear, and then you move over to square, you've got to have both axes represented. That's why it's 12 times 12. When you go cubic, you have to have all three axes represented, so it's 12 times 12 times 12. That's why the numbers get bigger like that. Okay, so let's do a problem. Okay, so we start with okay, 1.12 square kilometers. Now, a lot of errors occur because everyone thinks you've got to multiply the 112 square it. It's already been squared. Just leave it alone. All right, we need to go from kilometers to inches. Okay. Remember the givens always has to cancel. So how many square meters is in a square kilometer? Well, first of all, how many thousands, excuse me, how many meters are in 1 kilometer? 1,000. Well, because it's a square kilometer, we have to square it. Okay, now we have square meters. Now we have to go to inches. We have a conversion factor going from inches. We have inches to centimeters. We don't have inches to meters. What needs to go between these two? Centimeters and meters. So let's move that over. And how many centimeters are in a meter? Think of dollars and cents. How many cents are in a dollar? 100. Because you're working with square centimeters, that's 100 has to be squared. Okay, now. Does the centimeters cancel? No. This has to be square centimeters. So the 5.54 also has to be squared. All right. So everything canceled except for square inches. And what are we trying to calculate? Square inches. So whenever you see square or cubic, remember you've got to be squaring and cubing your conversion factors. So we're looking at 3 sig figs, infinite. The answer is going to have 3 sig figs. So why don't you all make sure you get the same answer as I got here. Go ahead and work that out. And you can go for the 1,000, you can go 1,000 carat squared. If you want, or you can just go 1,000 times 1,000. Those three are all. Carat means exponential. So that's that squared. Or x squared is 1,000 times 1,000. All of them. So work through that on your calculator, make sure you end up with the same answer. And you've done the 3 sig figs. Okay, did anyone not get the same answer? Okay, let's go on. By the way, I did post the video from yesterday. And I'll show you in a minute. It's in module. Okay, so let's look at another type problem. You saw a sign that said 34.5 kilometers per hour. What is this speed in miles per hour? So what's the given? 35.4 kilometers per hour is the given. We're starting with a fraction. So our answer is going to be a fraction as well. Okay? Start with a fraction, end with a fraction. Start with a single number, end with a single number. But, oh, okay, so if we look at what's given and what's to be calculated, the hours are fine. We don't have to modify the hours. We have to modify the top. We need to get kilometers, miles. So when we multiply so how are we going to do this? Well, we can get meters and feet. When you get kilometers and meters, once we have feet, we can go to miles. It looks like it's going to be 3-ish steps. Okay, so we need to write these down. We have. Okay, so let's move the kilometers to meters. Okay, we're in meters now. Okay, so let's convert the meters now to feet. And that is what, 328. And now we have feet. And we're gonna go feet to a mile. And that's what 328. Okay, so now we have miles per hour. The hour here wasn't. Now, sometimes you have to use the denominator has to be converted as well. So then you do the same thing with the denominator, you get a cancellation problem. Again, this is just cancellation. You get a cancellation, again, that's where you want to be. Basically, every single problem is given, when you try to calculate, you put conversion factors. To get there. Every single time. You have to be careful if you're using the square meters or square anything, the cubic anything, and then you have to square the cubic. Go to the fraction, you get angle fraction. Yeah, you use the fraction bar. Okay. And you started very simple with one stepper. Now we look at that. 3 and 4 steps. Yeah.
You should how you got that. I can't read them. That decimal point off.
Well. Let me just redo it to make sure that. Same thing. So what did you get? 2 point?
I got 20.7.
And use all this, my same numbers. Multiply 34 times 1,000 times 328. Hit the divide key, 5280. Okay, cool. Well, I've been known to. Sometimes when you turn your calculator on and you hit a number, it doesn't register right away. So you have to let the operating system and the calculator settle down before you're punching. Yeah,
How did we get the? Over here? Where did it go?
in the top table. Yeah. But again, if you download mine, it's clearer which is infinite and which is not. All right. That's what I wanted to do today. Go over the multi-step process of solving word problems. So every word problem, for example, one of the take-home problems I had. I want to end this recording here.